Ever get that eerie feeling like everyone around you is just kind of going through the motions?
Yeah.
Like a world full of robots and no one's really home. Well, get ready, because we're about to dive deep into a concept that explores exactly that, the nature of consciousness.
Ooh, that's a big one.
It is a big one. We've got a whole stack of academic excerpts here talking about philosophy of mind, neuroscience, dense stuff.
Sounds intense.
It is. But we're here to break it down, make it fascinating and understandable.
Well, I'm ready when you are.
Right. Let's jump in. So tell me, what makes this consciousness thing so tricky to figure out?
Well, one of the big challenges is this thing called the hard problem of consciousness.
Okay, hard problem. I'm intrigued. Lay it on me. What makes it so hard?
All right. Imagine a world where people act just like us, talk, walk, work, but they don't actually feel anything.
Oh.
No joy, no sadness,
Yeah.
no pain, like incredibly lifelike robots just going through the motions.
That's kind of creepy.
Right. And that's the hard problem. How do we explain how a bunch of neurons firing in our brains create this subjective feeling of experience?
Okay, I think I'm starting to see why that's a problem.
Oh.
So we can explain how the brain processes information.
Yeah.
Right, like how our eyes detect light and our brain says, hey, that's red.
Right. Exactly. Those are what we call the easy problems of consciousness. We can map out those neural pathways, see the mechanics of those cognitive functions.
But explaining why those processes actually feel like something to us.
That's the real head-scratcher.
It's like we can build a car and understand every single part, how they all work together.
Uh-huh.
But that doesn't explain the feeling of driving it, the wind in your hair, the freedom of the open road.
You got it. That's a perfect analogy. One of the excerpts you shared actually puts it this way. The problem of consciousness is puzzling in an entirely different way. An analysis of the problem shows us that conscious experience is just not the kind of thing that a wholly reductive account could succeed in explaining.
So if just explaining the mechanics doesn't cut it, how are scientists even approaching this? How do they study the subjective feeling of what it's like to experience something?
Well, one approach is to look for what are called neural correlates of consciousness, or NCCs for short.
NCCs.
Yeah.
All right, break that down for me.
Basically, it's about trying to pinpoint the minimal amount of brain activity that's needed for a specific conscious experience.
So like, what's going on in the brain that allows us to experience the color red?
Exactly. It's like searching for the brain's secret code for each and every experience.
That sounds incredibly difficult.
Oh, it is. It's like trying to find a needle in a haystack. The brain is so incredibly complex with layers upon layers of activity.
And different experiences probably involve totally different mechanisms.
You got it. And on top of all that, our tools for actually seeing the brain in action are still pretty limited.
Plus, we can really only ask humans what they're experiencing.
Right, exactly. I mean, we can't exactly ask a rat what it's like to see red.
So how do we know if my red is the same as your red? What if someone's red is my green? Could we ever really know if we're seeing colors differently?
That is a huge question. It gets to the heart of the mystery of qualia.
Qualia. Okay. Now there's another term for the glossary.
Qualia refers to the individual subjective feel of an experience, like what it's actually like to see the color red, not just the process of perceiving it.
Okay, I'm following. So far, so good.
Good, because now it gets even weirder. There's this idea of inverted qualia, meaning someone could be seeing the world with completely reversed colors, but they would behave exactly like us.
Whoa. Wait. So someone could be looking at a ripe strawberry, but experiencing it as green, but they'd still call it red and act like it's red.
That's the idea. It really makes you wonder if we can ever truly know if our inner experiences actually match up.
That's wild. My mind is officially blown just thinking about that.
Yeah.
And is there any evidence at all for this inverted qualia thing?
Believe it or not, there is. One of the excerpts mentions something called pseudonormal vision.
Pseudonormal vision.
It describes how a genetic quirk could actually cause some people to see colors in a reversed way.
So there could be people walking around right now, seeing a whole different rainbow than I am.
It's possible. And the research states that what appears red to a normal person to a certain degree will appear green to a pseudonormal person to roughly the same degree, and vice versa. In this sense, pseudonormal people are red-green inverted.
Wow. That is incredible to think about, that something as basic as color could be so subjective. It really highlights how difficult it is to study consciousness, just using objective methods.
You're absolutely right. We need ways to bridge that gap between the physical brain and the feeling of experience.
You mentioned earlier that studying dreams might be one way to help bridge that gap. How so?
Well, think about it. When we dream, we're experiencing a world that feels real. Even though it's all created by our own minds, it's like our own personal virtual reality, complete with sights, sounds, emotions, and that feeling of actually being there.
So by studying dreams, we can see how the brain creates conscious experiences without being tied to the real world.
Precisely. In dreams, we're detached from sensory input and we're not taking physical actions. It's like pure, unfiltered experience, isolated from everything happening in the outside world.
That's fascinating. It makes you wonder if dreams are like a sneak peek into how consciousness actually works.
It's definitely a compelling idea, and researchers are using all sorts of techniques, like brain imaging and dream reports, to try and decode the neural activity behind these dream experiences.
So dreams offer a really unique perspective on consciousness. But what about other altered states of mind, like the ones induced by hallucinogens?
Another fascinating area of research, studies using brain imaging techniques like FDG-PE scans have shown that these altered states brought on by substances like ketamine or psilocybin don't actually break the brain.
So the brain is still working. It's just working differently.
Exactly. The activity levels within certain brain networks change dramatically. And that's what leads to those profound shifts in subjective experience.
It's like the brain is a symphony orchestra, and hallucinogens are messing with the tempo, the volume even which instruments are playing. It creates a totally different musical experience.
No, that is a fantastic analogy. It really shows how dynamic the brain is and how subtle changes can have a huge impact on our conscious experience.
Okay, let's shift gears a bit and talk about something else that's been blowing my mind. Mirror neurons.
Ah, yes. Mirror neurons. These were first discovered in monkeys, and they are pretty mind-blowing.
It sounds like something straight out of a sci-fi movie.
I know, right? So these are special brain cells that fire both when a monkey does something and when it sees another monkey doing the exact same thing.
It's like the monkey's brain is mirroring the other monkey's actions.
Exactly. But it turns out mirror neurons aren't just about mimicking movements. They seem to play a key role in our ability to understand the intentions and emotions of others.
It's like our brains are hardwired for empathy and connection. No wonder we can feel what others are feeling.
Exactly. Mirror neurons could be the very reason we can share experiences on such a deep level.
This is incredible. It's
Yeah.
like we're all linked through these tiny neural mirrors. Okay, before we get too lost in the interconnectedness of it all, let's talk about attention. How does attention shape what we're consciously aware of?
Think of attention like a spotlight. It highlights certain parts of our experience, while others fade into the background. What we pay attention to becomes part of our conscious awareness, and everything else kind of disappears.
So it's not just that we're not consciously aware of everything, our brains might not even be fully processing it all.
That's the idea. Some researchers believe that our visual experience is actually much more limited than it feels. Like our brain is filling in the gaps and creating this grand illusion of complete perception.
Hold on. So we're walking around with all these mental shortcuts, and our brains are just making up the rest.
It's kind of like watching a movie. Our eyes dart around taking in snapshots, and our brain stitches them together into a smooth experience. But we're only really seeing a tiny fraction of what's actually there.
And there's that thing called Troxler fading, right? Where if you stare at one spot, objects in your peripheral vision can actually vanish.
Exactly. It's a great example of how our brains prioritize what we focus on, and how easily the rest can slip away from our conscious awareness.
It's like our brains are constantly editing our own reality show. Most again, speaking of deep thoughts, let's talk about the connection between emotions, the body, and consciousness.
This is a crucial link. Our emotions aren't just in our heads, they involve actual physical changes happening in our bodies. Think about that racing heart, sweaty palms, rapid breathing you get when you're feeling fear or excitement.
Right, so it's a two-way street. Our thoughts and feelings affect our bodies, and our bodies affect our conscious experience.
Exactly. The research you shared mentions the autonomic nervous system, which controls all those automatic bodily functions like heart rate and breathing. And by measuring things like skin conductance or GSR, we can actually see how our bodies are reacting to emotional triggers.
But there's still a debate about whether the conscious feeling of an emotion happens before or after those bodily changes, right?
Yeah, it's the classic chicken and egg problem. Do we feel fear and then our heart starts racing? Or does our heart race first, then we interpret that as fear?
It's like trying to figure out which came first, the thought or the feeling.
The answer is probably much more complex than a simple cause and effect. Emotions involve this dynamic interplay between the brain, the body, and the world around us.
This deep dive has already taken us from philosophical zombies to dreaming brains, to the mysteries of color perception. It's been a wild ride so far.
I've only just scratched the surface. There's so much more to explore in the realm of consciousness.
Well, I'm definitely ready for more. What other mind-blowing insights await us in the next part of our journey?
Well, how about we explore the evolution of emotions? One of the excerpts describes some fascinating research on rats that suggests they might actually experience something very similar to joy.
Wait, rats can experience joy.
It appears so, especially when they're tickled. They emit these high-frequency ultrasonic sounds that actually resemble laughter.
So tickling a rat is like telling it a joke.
It seems to trigger a similar response, and it suggests that joy, or at least some form of positive emotion, might be much older and more basic than we thought.
That's incredible. Something as seemingly human as laughter could have roots that go way back in our evolutionary history. This deep dive is making me look at the world in a whole new light, from the colors we see to the feelings we might share with other creatures.
I'm glad to hear it, and there's so much more to come.
What else can we look forward to in the next part?
Well, we've just started to touch upon the evolution of consciousness. Next time, we'll delve into that even further. From ancient tools to Tibetan Buddhism, and believe it or not, we'll even explore how the strange world of quantum physics might be connected to our conscious experience.
Okay, now you're really speaking my language. I can't wait. Tune in next time as we continue our deep dive into the mysteries of consciousness. Welcome back to our deep dive into consciousness. Last time, we explored some pretty mind-bending concepts about subjective experience.
Yeah, we did.
But now I want to take a trip through time and explore how consciousness might have actually evolved.
Ooh, I like where this is going.
One of the sources, an archaeologist named Stephen Mithen, argues that we can actually get clues about early consciousness by looking at the tools our ancestors created, specifically hand axes that appear in the fossil record about 1.4 million years ago.
Hand axes. Those stone tools.
Yeah, exactly. What's so special about those?
Well, Mithen believes that making these hand axes required more than just basic motor skills. It suggests planning and understanding of symmetry and maybe even some internal language.
So these hand axes are like a window into the minds of our ancestors.
That's the idea. It hints at a level of cognitive complexity that suggests a more advanced form of consciousness than we might typically imagine for early humans.
It makes you wonder about their inner world. What were they thinking and feeling as they crafted these tools?
It's a fascinating question. It shows how even simple artifacts can give us glimpses into the evolution of the human mind.
So hand axes were a big step. What came next in the evolution of consciousness?
Well, Mithen points to the emergence of art and agriculture, around 50,000 years ago, as a major turning point. These activities required abstract thought, symbolic representation, and complex social cooperation.
It's like a cultural explosion. Humans are suddenly expressing themselves through art, cultivating the land, and forming more intricate societies.
Mithen sees this as a budding and flowering of human consciousness, a time when our mental capacities reached new heights.
Okay, so we've journeyed through millions of years of evolution, from hand axes to cave paintings to the agricultural revolution. But what other perspectives can help us understand this elusive thing we call consciousness?
One of the sources suggests looking beyond Western science and philosophy to the ancient wisdom of Tibetan Buddhism.
Tibetan Buddhism. Okay, that's interesting. What does Tibetan Buddhism have to say about consciousness?
Well, it emphasizes the importance of refining the mind through meditation as a way to directly explore consciousness.
So it's not just about observing the brain from the outside, but actually training the mind to become a more precise instrument for understanding consciousness from within.
That's a great way to put it. It's a first-person approach, complementing the third-person approach of neuroscience.
This brings up the idea of neurophenomenology, mentioned in one of the excerpts. What is that exactly?
It's a field that combines the rigorous first-person descriptions of conscious experience cultivated in meditative practices with the objective findings of neuroscience.
So it's like a dialogue between inner experience and scientific observation.
Exactly. It aims to bridge that gap between subjective experience and objective data, creating a more holistic understanding of consciousness.
It makes sense that we need both perspectives to fully grasp something as complex as consciousness.
It's like trying to understand a coin. You need to look at both sides to get the full picture.
Okay. We've talked about first-person and third-person perspectives, but one of the excerpts also mentions a second-person perspective. What's that all about?
The second-person perspective highlights the importance of interaction and communication in shaping consciousness. It's about the I-you relationship, how our minds change and evolve through our connections with others.
So it's not just about what's happening inside our own heads, but also how we connect and communicate with other minds.
Precisely. And the excerpt actually makes this point quite clearly. Consciousness is not to be explained either by an examination of objective third-person its, as in brains or computer models, or by an examination of subjective first-person I's, as in personal experience, or even by a combination of both. Consciousness also involves interpersonal relations and requires an examination of second-person I-you experience.
Wow. This deep dive is really expanding my understanding of consciousness. We've explored the evolution of the mind, the wisdom of ancient traditions, and the importance of social interaction. What other fascinating perspectives can we add to this tapestry?
How about the insights of a poet and scientist?
A poet and scientist. Okay, now I'm really intrigued.
The source material delves into Goethe's approach to science, which emphasizes direct qualitative observation, especially when studying living forms.
Wait, Goethe? The poet who wrote Faust.
The very same. He was also a keen observer of nature and believed that true understanding came from direct engagement with the phenomena, not just abstract theorizing.
So how does this relate to studying consciousness?
It suggests that we need to develop the capacity to perceive subtle patterns within our own subjective experience, to see consciousness in its living form, so to speak.
It's like becoming an artist of inner observation.
Exactly. Cultivating a refined attention to the nuances of our thoughts, feelings, and perceptions.
This is making me rethink how I approach my own inner world.
Okay.
We've explored consciousness through philosophy, neuroscience, ancient traditions, and even poetry. Now let's get a bit more quantum.
I was hoping you'd say
I
that.
had a feeling you'd be excited about this one. The source material touches on the possibility that quantum physics might actually play a role in explaining certain aspects of consciousness, particularly the binding
The
problem.
binding problem.
Oh, remind me again, what is the binding problem?
It's the question of how all of our different sensory experiences, color, shape, motion, smell, sound, all of it, how do they all come together to form a single unified conscious experience? How does the brain combine all their separate bits of information into the seamless experience of, say, seeing a red apple rolling across a table?
Right, it's like our brains are constantly putting together a jigsaw puzzle of perception. But how does quantum physics fit into all of this?
Well, some researchers suggest that quantum phenomena, like entanglement and superposition, might actually be happening in the brain. And this could potentially allow for the integration of information in ways that classical physics just can't explain.
So it's like our brains are using quantum entanglement to solve the binding problem.
That's one of the ideas being explored. The source material mentions concepts from condensed matter physics, like boson condensation and quantum coherence, as potentially relevant to this question.
I'll be honest, this is where my brain starts to feel a little fuzzy. Quantum physics is definitely on the edge of my understanding.
Oh, it's a complex and mind-bending field, for sure. But the key takeaway here is that some scientists believe that quantum processes might actually be essential for understanding how our brains create a unified conscious experience.
All right, I'm willing to keep an open mind. Speaking of open minds, let's finally address the elephant in the room. Could our reality be a simulation, just like in The Matrix?
Ah, the matrix hypothesis. It's a fascinating idea. And the source material actually argues that it's a coherent hypothesis that can't be definitively ruled out.
But how can we even entertain the possibility that everything we experience is just a sophisticated computer program? I mean, come on.
Think about how far computer technology has come. In just a few decades, we have virtual reality systems that are becoming increasingly immersive and indistinguishable from physical reality.
Okay, but that's still just technology. How could a computer program explain the entirety of existence?
The argument is that computation itself might be the fundamental building block of reality. If our brains are essentially biological computers, processing information and generating our conscious experience, then what's to say that reality itself isn't also computational at its core?
So instead of atoms and molecules, we're made of bits and bytes.
It's a radical idea, but one that some physicists and philosophers take seriously. And it leads to some mind-bending questions. If we are living in a simulation, who created it? And what is its purpose?
Whoa, that's getting deep. It's like trying to imagine the mind of the programmer who created our reality.
And it raises the question of whether it even matters if we're in a simulation. If our experiences, relationships, and emotions feel real, does it change anything if they're ultimately generated by a computer program?
This deep dive has taken us on a wild ride. We've explored the evolution of consciousness, the potential of quantum physics, and even the possibility that we're living in a simulated reality. It's a lot to process.
We've covered an incredible amount of ground, from the hard problem of consciousness to the mind-bending ideas of Tibetan Buddhism and the matrix hypothesis. And we've only scratched the surface.
I'm ready for more. What other fascinating insights await us in our final segment? What are the implications of all of this?
Well, in part 3, we'll tackle some of the thorniest questions in consciousness research. What does the matrix hypothesis mean for our understanding of the world around us? Is there any way to prove or disprove the simulation theory? And perhaps most importantly, where do we go from here in our quest to understand the nature of consciousness?
All right, folks, buckle up for one last mind-bending ride. We'll see you in part 3 for the grand finale of our deep dives into consciousness.
All right, we're back for the final part of our deep dive into consciousness.
It's been quite a journey.
It really has. We've gone from exploring the very nature of subjective experience to considering the possibility that we might be living in a simulation.
The matrix hypothesis.
Right.
Exactly.
Yeah.
So now that we've entertained that mind-blowing idea, I have to ask, where does that leave our understanding of the external world? Does it even matter if everything we experience is just a sophisticated computer program?
That's a big question, and one that philosophers and scientists are grappling with. But here's the thing. Even if the matrix hypothesis is true, it doesn't necessarily mean there's no external world. It just suggests that the world might be built on something different than we traditionally imagine.
So instead of bumping into a table, I'm bumping into a bunch of code. That's really good at pretending to be a table.
You could think of it that way, but it might be more helpful to see it as an upgrade to our understanding of physics. If reality is fundamentally computational, then the laws of physics, the forces that govern the universe, they might all be expressions of a deeper computational code.
Okay, that's a pretty big if. But is there any way to actually prove or disprove this simulation theory?
That's the tricky part. It's a really slippery concept to test. The research you shared suggests that the matrix hypothesis is logically possible, but that doesn't automatically make it true. There's no definitive test we can run to say for sure whether we're in a simulation or not.
So we're left with this unsettling possibility that we may never know for sure. It's kind of a mind trip.
It's a bit like living in a locked room. We can examine everything inside, but we can't see beyond the walls to know for certain what lies outside.
That's a great analogy. It really drives the point home.
Yeah.
So even if we can't definitively prove or disprove the simulation theory, just the fact that it's a coherent hypothesis opens up a whole new way of thinking about the world.
Absolutely. It forces us to question some pretty fundamental assumptions about the nature of reality. And it leads to some pretty mind-bending possibilities, like maybe consciousness itself is more fundamental to the universe than we previously thought.
We've covered so much ground in this deep dive. We've explored the philosophical and scientific frontiers of consciousness, from the hard problem to the matrix hypothesis. What an incredible journey.
It really has been. But remember, the journey of understanding consciousness is really just beginning.
Where do we go from here? What are the next steps in understanding this elusive phenomenon?
Well, I think one path forward is to keep refining our scientific tools and methods. We need even more precise ways to measure and manipulate brain activity, to really crack the code of conscious experience.
And to develop new technologies that let us observe and interact with the brain at an even deeper level.
Yes, exactly. But technology alone won't solve the mystery. We also need to keep refining our philosophical frameworks to come up with more nuanced concepts and theories that can actually account for the subjective qualitative aspects of experience.
So we need a new language to talk about consciousness, one that bridges the gap between subjective feelings and objective science.
I like that. A new language for consciousness.
And we need to embrace even more interdisciplinary approaches, bringing together insights not just from neuroscience, but from philosophy, psychology, physics, computer science, even the arts and humanities.
It's like creating a grand symphony of perspectives, each discipline contributing its unique sound to create a richer, more harmonious understanding of the whole.
Well said. And to our listeners, we hope this deep dive has sparked your curiosity, challenged your assumptions, and left you with a renewed sense of wonder about the mystery of consciousness. It's been quite a journey for us too, and we're grateful you joined us.
Until next time, keep exploring.